Assalamualaikum and hi, I am Nasrin Ashila from Group 3 together with my team member Hafiz, Haziatul, Hazizat and Tivan. In this project, we use Matlab to analyze the ECG signal by performing time domain analysis, frequency domain analysis, pole zero analysis and design suitable filter to remove the unwanted noise. So based on the data that was obtained from the ECG2 file, the data was transferred in Matlab by using the command load ECG2.mat, and once the data are saved in the workspace, we can use this data to plot the input signal in continuous time domain by using a simple command, which is the plot ECG2. We can label the x-axis and y-axis with the command x-label and y-label. From this plotted signal, you will notice that the x-label is time, while the y-label is the amplitude of the signal. Moving on with the same data, we can also plot the discrete time signal by using the command stem ECG2, and the result will as in figure 2. The signal plot is labeled the same as in figure 1. Both of the plotted signal were given a title, which is the ECG2 continuous time signal for figure 1 and ECG2 discrete time signal for figure 2. So we have used a FIR filter to design our low pass filter. It was built using the filter builder in Matlab. Using the same concept of the command, we applied the plot and step command onto the output signals to plot its continuous and discrete time signals, and the results are as shown in the figure 3 and figure 4. By comparing the input signals in figure 1 and figure 2 with the output signal, we can notice that the noise in the signals are now reduced due to the filtering that it have gone through. Thus, we are now able to observe and analyze the signals more clearly than before, so the analysis will be more readable and accurate.
Hi, my name is Muhammad Hafiz bin Shahrir, and for this presentation, I will explain to you the DSP keyword that is related to this assignment, which is the convolution. So in this LTI system, we use difference equation for convolution process. So yn equals to xn times hn is used in this part. So xn is basically the discrete time signal, and this is the syntax coding that we use to generate it. And hn is the impulse response, or also known as the filter that we have built to reduce the noise in the original ECG signal given. So this is the filter setting, and this is the syntax to use the filter, and below it is the syntax to generate the yn signal, which is the output for the discrete signal that have been filtered.
Hi, my name is Nur'ain, and today I will explain to you about the FIR filter that will be designed to filter out the noise from ECG2 signal. The first function we'll be using is the filter designer function. We use the functions to call out the filter designer toolbox in order to construct the filter that we need for this project. Then we use the functions filter here after we export the filter from the filter designer toolbox into the object form. Then we will do the Fourier transform on the figure 2 signal and plot into our graph, which is the frequency domain, and plot in time domain and discrete time domain by using function plot for continuous time and stem for discrete time. The specifications for the filter design is we will be using the FIR bandstop equiripple filter. The stop band frequency is 400 Hz and 1600 Hz. The filter is designed based on the noise that we found on the ECG2 signal. This is the graphical representations of our filter signal. From the graph, we can see that there is less noise in the continuous and discrete time domain signal, and this is the pole zero plot for our filter. We have around 100 poles and 1 zero. Lastly, I will show the output signal in the frequency domain. The noise in the frequency domain disappeared after we applied the filter. We can conclude that the filter successfully eliminates the noise. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Azizat. So I'm going to explain about discrete time Fourier transform. So this is our ECG2 signal. So first we filter it. Then I'm using stem function to get the impulse. So then we only want to get the y-axis data. So I'm using get my y. Then we get y-axis data. So then I'm wrote DTFT formula here. And then we compile and run it. So this is our result for DTFT. for ECG2 signal.
I am Tiventhiran Vadivelu. I'm here to explain about windowing method. So, designing FIR filter based on windowing technique is basically done by truncating ideal filter, which is an IIR type, into FIR type. So, windowing method is in 4 types, which is rectangular type, Hamming type, and also Blackman type. Basically, we'll be using rectangular type of windowing method. So, basically, I'll be showing that how to transfer original signal into a filtered signal. So, there are 3 methods which can be done to transfer a signal using a windowing method. First, we'll be using a command, and that command is FIR1. And second, we'll be also using a command that is design filter. And the third command, third is not a command, third is using a inbuilt designer app, which in a DSP package of Matlab. So by using these three kind of technique, we can determine the filtered signal of a signal. So basically, this is the output filter signal of this signal that I received. Thank you.